For our second example, under areas by integration, so find the area in the third quadrant bounded by the curve x is equal to y squared plus 2y. Okay, so in this given curve, so this is x is equal to y squared plus 2y. So you must recognize again that this is still a parabola. Okay, so to graph this, so we must to graph this easier. So we must express this in terms of standard form. Okay, so we have x is equal to y squared plus 2y. So completing the square, so the third term here, missing third term, is by completing the square, it's positive 1. Okay, so if we add positive 1 on the right side of the equation, we must also add 1 on the left side of the equation. So this will become x plus 1 is equal to y squared plus 2y plus 1. Okay, so factoring this, so this will become x plus 1. So since this now is a perfect square trinomial, so this will become y plus 1 squared, or y plus 1 squared is equal to x plus 1. Okay, so this parabola now, so by inspection we can see that it's, since it is y that is squared, so therefore this is a parabola opening to the left. Okay, and since this here is positive, so this is opening to the left. Okay, with vertex at hk, so h here is equal to negative 1 and k here is equal to negative 1. So the vertex is at negative 1, negative 1. Okay, so if we graph that, so again we are finding the area in the third quadrant. So let's say it looks like this. X and y. So negative 1 is somewhere here. Okay, and then it's a parabola opening to the left. Oh, sorry, opening to the right. So this is the right side. Sorry, my bad. Okay, so it's parabola opening to the right. Okay, so but we don't know its intersections with the y-axis, so we can solve that by setting x is equal to 0. Okay, so here, so for y-intercepts, so take at x is equal to 0. So at x is equal to 0, so this will now become y squared plus 2y is equal to 0. So factoring, greatest common factor is y, and then what will remain is y plus 2 is equal to 0. So equating the factors to 0, so we will have y is equal to 0 and y plus 2 is equal to 0, or y is equal to negative 2. Okay, so therefore we will have the points at x is equal to 0, y is equal to 0, and at x is equal to 0, y is also negative 2. So let's say negative 2 is in here. So this is negative 1, negative 1. This is negative 2. Okay, so your parabola should look like that. Okay, okay, and we are going to solve for this area here. Okay, so in doing that, so the strip okay, that we are going to use must be a horizontal strip. Okay, so it must be a horizontal strip. Okay, so the width of the strip, okay, so this one, so its width is dy and its length is x. Okay, but you have to take note the orientation of the strip. Okay, so if the strip is measured from left to right, okay, so say for example I'll draw another strip here. Okay, so if the strip is drawn from left to right, that is a positive x. Okay, so however, if the strip is drawn from right to left, that is, this one is a negative x. Okay, so it's important to note that because we don't want to solve for areas that are negative. Okay, because areas should always be positive. Okay, so with that, okay, so again take note, if it's measured from right to left, so it should be a negative. So the same with y. Okay, so for dy, okay, so if y is measured, if we measure y from from downward, from lower to higher, okay, so it's positive y. But if we measure it, okay, if we measure it from above to below, so it's negative y. Okay, so you must always remember that we start from the axis. Okay, so therefore this area now will become a is equal to integral of, we have negative x dy from, so limits of y from y is equal to negative 2 to y is equal to 0, from negative 2 to 0. Okay, so since x is equal to y squared plus 2y, therefore negative x is equal to negative y squared minus 2y. Or we can take the factor out the negative. So negative, oh sorry, this is from negative 2 to 0. So negative integral of y squared plus 2y dy from negative 2 to 0. Okay, so integrating that, so that will now become negative, so this integrating y squared dy, so that is 1/3 y cubed plus integrating 2y, so that will be 2y squared over 2, so it's, oh sorry, this is y cubed, so plus y squared only from negative 2 to 0. So substituting the limits, so we will have negative 1/3 times 0 cube plus 0 squared minus 1/3 times negative 2 cube plus negative 2 squared. Okay, so this will now become negative, so this will be 0 and this is also 0. This will become negative 1/3 times negative 8, so this is negative 8 negative 8 negative 8 thirds. So negative 8 thirds times negative, so that is positive 8 over 3. And then this will become 4 and negative 4, so minus 4. And subtracting, so this will become negative 8 over 3 minus LCM of 3 divided by 1 times 4, that is 12. So this will become negative 8 minus 12, so negative 4 over 3. Okay, or so we have positive 4 over 3 square units. Okay, so it's important to take note of that. Okay, so whenever we have positive x or negative x or negative y in our illustration. Okay, so this is why the graph is very important in solving the areas, okay, of curves, because the graph, okay, so will tell you, okay, so what are the limits, what strip should be used whenever we have a negative strip. Okay, so those things are very important. So therefore, part of your solution should be the illustration, okay, or the graph. Okay, so it's part of your solution, and I will not consider your solutions if you don't have the graph. Okay. Okay, so that's it. So look how important that was. So if we did not note that we have a negative strip, okay, so if there was no negative in here, if we did not consider the negative, then there will be no negative in here, and we will be left with a negative area, okay, if there was no negative. Okay, so that's how important that is for your solution. Okay, so that's all, and good luck.